Okay, so today's topic is scatterplot, covariance, and correlation. So scatterplot is a visualization that shows the relationship between two variables. We are not sure which variable is independent variable and which variable is a dependent variable between two variables. It is decided the relationship between two variables is decided by a theory, substantive theory. So, but this class is not about a theory, substantive theory, but this class is about methodology. So, but in the end, we're gonna write a final research paper with a full analysis. So eventually, we need theories because hypothesis is backed up by the substantive theory. So we really need to do literature review to find out the theories for your research hypothesis. But at this point, since this is very beginning time of the entire class, rather than talking about theory, I just wanna jump into the method itself. Okay, so before we talk about the relationship between two variables, so I'm gonna introduce a scatterplot, and scatterplot is visualization to shows relationship between two variables. So it can be, for instance, education and wage. If somebody has a higher education attainment, if the one has a higher wage, on average, yeah, some people are really interested in that kind of topic, educational statisticians, right? Or other people like want to find the relationship between salaries and the CEO performance, So if salary is high, then if the CEO performance is really good, if that logic in that way, the salary becomes X variable and CEO performance is Y variable. Of course, you can convert the relationship between X and Y if there is a backup theory to support your argument. For instance, like if X variable is CEO performance and then Y variable is salary, for instance, you're gonna make the CEO performance better. Then let's say, okay, work appraisal, criteria include like incentive salary system. Then not just salary based on seniority. If you if your company set up like incentive system into the basic seniority based salary, then you want to see the effect of the incentive work appraisal new system on the CEO performance. Then in that case, in that scenario, incentive salary system is an X variable, independent variable, and the Y variable is the CEO performance, right? So depending on what theory you choose, the relationship between two variables are changed. Well, anyway, as I said before, it's not a time about the theory. So, X and Y, or like two variables, when you do not know the specific name of the variables, you just say X variable and Y variable, right? Yeah, so between two variables, X and Y, to explore the relationship between two using visualization tool. Yeah, the most effective one, I believe, is called Scatterplot. Okay, so all right, here, independent variable is labeled X, and it is usually placed on the horizontal axis, horizontal axis, and dependent variable is y, is mapped to the vertical axis, right? So, if you place education on the x-axis, education becomes x variable, independent variable. Wage, if you place wage on the y-axis, then the y is wage. Dependent variable is the wage, okay? So how strong the relationship between two variables is, or what the direction of the relationship is, and how the shape between two variable relationship is. These three elements are very important findings when you see a scatter plot, okay? Okay, so here, strength. We can say how closely related are the two variables. Is the strength between, for instance, education and the wage is weak, or is the relationship is strong? Yeah, that's the strength, okay? Direction. So which values of each variable are associated with the values of the other variable? The relationship is positive or negative. So positive meaning if education is high, the salary tend to be high. That's a positive relationship. If the education is high, then the wage is low, even though it's not realistic, and we call that negative relationship, right? And the shape. Okay, so if that shape of the relationship is linear means a straight line, okay? If it is linear or not, linear or curvilinear, or other form. So we have to figure it out. So correlation is assumed as linear, but actually when you see the relationship using a scatter plot of x and y variable, sometimes it's not, actually most of the time, it's not necessarily linear. So in that case, correlation, the index or the value that the any software computer, the statistics software program is derived from the calculation, machine calculation is not guaranteed a linear relationship, even though it shows a number. So that is why we need to see a scatter plot between two variables before you run an analysis, for instance, correlation or regression, things like that, okay? So you really need to see the visualization first of all. When you want to see the relationship, okay, and before you report the number, correlation index number, you need to provide a scatter plot, and you have to bring your judgment call. Okay, that scatter plot shows XY relationship is linear or not. You have to justify that. I mean, if it is linear or not, you have to write down. Okay, some dots looks like outlier, but we have to investigate that outliers looking dots. But except for those a couple of outliers, everything looks like linear. So I conclude like this relationship between blah blah x variable and blah blah y variable is linear. So we can use correlation, something like that. So I'm gonna give you this kind of questions in one homework assignment. Anyway, when we want to use one variable as predictor of the other variable, so predictor. So if you see somebody's education attainment, if he's a high school dropout, if he's master's MBA degree holder, that is a predictor to predict the person's wage or salary, right? Yeah. In that case, education is a predictor. Okay. And the wage or salary is outcome variable or criterion variable. Okay. So here are some synonyms. Okay. So X variable, independent variable, predictor, explanatory variable. These are the same meaning, same kind of word, same meaning, X variable. What about the Y variable? The Y variable is dependent variable, the criterion variable, predicted outcome variable, outcome variable or predicted variable, right? So X variable is used on the X-axis. Y variable, the values, individual values, are placed on the Y-axis, right? Okay. So this is examples of scatterplots. So first one, strong positive linear. So when one dot is placed on the one on the X-axis, and there's a lot of values here, right? From very low value on the Y and from between 1 and 2, pretty much on average, okay? But the X variable, one X value is, let's say here, these guys, these values on the Y axis are, comparatively speaking, the higher than this one, right? So this is positive linear. This is a strong negative linear. So X value is positive. The higher X values, the lower values on the Y, right? So this is negative. This seems, there is no relationship or very, very weak relationship. Okay. Yeah. Not like that. Not like sharp. Okay. They're just tangled around the zero, Here is interesting relationship. Okay, so between, with the center point, cut point 0, the relationship in the right side is positive. The relationship in the left side of the axis is negative relationship. So this is not linear relationship. This looks curvilinear relationship. Okay. So now, we will begin by dealing with the two general topics. So once you checked a scatter plot and it is linear, if it is linear, then you can use correlation. You can move on the second analysis, correlation. Correlation, scatter plot does not show a number. It just shows eyeballing, simple and quick visualization, but correlation provides a number. So you can compare one correlation with the other correlation, okay? So which correlation is higher than the other? Something like that, the relationship. You can compare the relationship between X and Y and the relationship between A and B, okay? So two different relationships, even though there are 4 variables, in that example. Anyway, so statistics that depict the strength of a relationship between two variables. These are also called measures of association. So the synonym, association, relationship, correlation, covariance. But correlation is kind of special. Why? Association, relationship, and covariance, they are not standardized. So when the two variables have this kind of unit, and the other two variables have a different type of unit, they cannot compare the magnitude each other, right? For instance, you cannot compare height and weight at the same time because they have different units, right? But if you standardize them, then they just have a comparable new number. Yeah, that is correlation. So correlation is a standardized association. Correlation is a standardized relationship. Correlation is standardized covariance. Independent and dependent variables are treated as random variables. Yeah. Variables that constitute random samples from the population so that the levels of the variables are not under the control of the researcher. Researcher does not manipulate the variables. The variables and values of each variable is collected randomly. That's what is it. So then, okay, correlation. I said correlation of one variable and the other variable is not specified as predictor and predicted outcome. It's just association, relationship. But regression includes substantive theoretical attributes in addition to correlation. So regression is more advanced approach than correlation. So regression is based on correlation, but you want to know the relationship, more accurate relationship between two variables. Which one should be first and which one should be later? So then we want to see which one is a predictor or which one is the outcome. Statistics does not decide that. Theory decides that. So once you have two variables, you have to go to literature review to do the literature review. Then you have to decide what variable should be a predictor and what variable should be the outcome variable, okay? It's not easy because some people prefer one relationship between X and Y, but the other people prefer opposite relationship. Then you have to you have two different competitive hypotheses, and the data that is used for your analysis should support one kind of theory, right? But you might have some kind of a personal preference which theory is more suitable, then you have to decide it. I mean, and then that decision, and based on your judgment call, should make sense. If you just argue something, doesn't necessarily mean that people agree with you. Okay, so that's why we have to go through the very in-depth literature review. Even though this is methodology course, we need to go through a very, very in-depth literature review. So sometimes we are confused. Wow, I wanted to be like a method expert through this PhD, 6701. But what am I doing now? I'm looking for substantive ideas, theories now. Yeah, but that's necessary. Yeah, that's necessary. You need very reasonable, plausible theories first. Otherwise, the statistics does not say anything meaningful. Okay? We are doing, inductive approach in the data science. They use inductive approach, data-driven approach. This statistics course, this is a statistics course. So we have to have substantive theory. So we are doing theory-driven approach. Okay, all right. I talk too much about theory right now. Why? I don't know. Anyway, dependent variables are treated as random variables, but independent variables is given. Okay. Of course, you also need to decide what the dependent variable is for your final paper, but theoretically, independent variable is treated as a fixed variable. So that's why some people call independent variable as an exogenous variable because it's just given from externally. But depending on what independent variable is chosen, then dependent variable is followed. That's why dependent variable is a random variable. Variables that constitute the only values of interest in the study so that the levels of variables are under the control of the researcher. Scatterplots, okay? Positive, strong relationship here, right? Okay, in the center, on the lots of dots, there's a line. This is a regression line. SPSS give that. You don't need to calculate all the dots, average, sum them up, and then average out, and then you make this one single regression line. Long time ago, we manually calculated and we did that, but not anymore. SPSS or SPSS does that, so we just simply use that convenient tool. Okay. We don't want, the purpose of this course is not to be a mathematical statistician, but we are applicant, okay, based on advancement of technology, okay. So then eventually our ultimate goal, based on the scientific statistical method, we want to predict, we want to predict the future. We want to use that analysis for generating better decision making. Ultimately, that is our ultimate goal, right? But before we go too far, we just focus on what kind of analytical techniques are available here. Okay, so that's why this course is regarded as a STEM subject, STEM course. So, this PAD 6701 is totally different from the courses that you have learned so far. So there's no guarantee that students who always receive A from other substantial contextual courses receive an A in this course. You have to follow the instruction and rubric. I give a question that I expect you need to answer like 1 + 1 = 2. But if you say like the highest mountain in the world is Mount Everest, yeah, you will receive 0. Yeah. There's long answer from some students. But if it is not valid, the answer is not valid to the question, yeah, you will get a 0. Okay, so don't put too long answer, but don't put too short answer. I have to see something based on the course lecture. Okay. Okay. As is true for many other characteristics of distributions that we wish to describe, parameters and statistics describe association between two variables. The most commonly used statistic in the Pearson product moment correlation. So we have some different types of correlation index, Spearman, Pearson. In this case, we assume all our variables are continuous variables. So in that case, when we want to see the, when we want to use linear relationship between two continuous variables, then we use Pearson correlation. Yeah, official name of Pearson correlation is Pearson product moment correlation. Okay? So R is correlation index. Especially R is a sample correlation. Okay? Let's say you collect the data. The data is a type of sample, right? So you have, externally, you have a population that you target, but you cannot collect all of the population, all of the people, right, from the population. So that's why you need to have a subset of the population, which is called sample. So sample correlation is called R, alphabetical letter R. But the population correlation is called rho. Greek letter here, Greek letter rho. Okay, population number, population value is called a parameter. In this case, correlation parameter in the population is called rho. But the sample that you have sample, right? And then you find a relationship between two variables from your sample. Okay, and you standardize it, standardize the association, the relationship between two. Then it is called correlation. And more accurately speaking, it is Pearson correlation. And sample correlation, there is sample correlation because that's derived from the sample data, right? So R, please be informed that the difference between R and rho, okay? R is alphabetical letter, sample statistics. Rho is Greek letter. Rho is a parameter. More specifically, rho is a population correlation. Okay? We never know the value of rho unless you collect the entire population data. But we do not do that because of the lack of time and money. We always do something dealing with the sample. So another problem is whether or not you derived from or compute something from the sample is really suitable to guess what the population parameters are. Guessing, we ultimately, we want to know the population parameter, but we cannot. So we indirectly have to guess what it is using sample statistics. But if your sample collection is biased, your sample statistics wouldn't be similar to the population parameter at all. This is a different problem, and this is not related to statistics directly. What I'm saying is related to research design and sample collection design. And you learned that in the prerequisite course PAD 6700, right? Research design. So another problem here, if you did not ace in the PAD 6700 class, then you will have a problem in this course again. So before you jump into the really in-depth analysis skills in this course, why don't you go back to 6700 to skim the main ideas? All right. if you do not have the course materials, just find out all Bobby's social problem, research design, any textbooks, or Bobby's sociology, research design textbooks are great. You can just read some topics from the textbook, and those books easily searched for on Google. If you can't find any, just email me. Okay, I have a couple of free access to research design books, so I can send it out. Okay, I tried to post it on the web courses, that website, but Dr. Goodman said, be careful about copyright. I don't know about copyright. What I found, those books were looked accessible for free online. It's still there. So I don't know about what he said. Actually, seems like there's no problem related to copyright. Anyway, he said don't post anything, any entire textbook for the author's right. So I just, it makes sense. Yeah. So, but if you contact me personally, yeah, I can give you the link. So I don't think that's a problem at all, because it's anyway offer than free. Okay. So here, same story here, strength. The relationship is strong, right? Regardless of positive or negative, the relationship is strong. A direction, positive sign or negative sign or no sign. And shape, linear or not. Okay. Here, important phrase here, best fitting straight line. Who made it up? SPSS, generated the line for us. Yeah. The last one. The last sentence is the most important, okay? In this slide. If a relation is not linear, Pearson correlation will not find it. So even though statistics SPSS gives you R number there, you should not use that because of the not linear relationship in the scatter plot. Does it make sense? Yeah. So you want to use correlation, but if it is not linear, then you have to use a different analysis rather than correlation. A different analysis, yeah, there are a couple of techniques. We're gonna get to that point later. Okay. Anyway, here important thing, scatter plot. You want to see visualization first, and then bring your judgment call if that is linear or not. Then if it is, judge as a linear, regardless of weak or strong. If it is linear, then you can use a correlation. You can report Pearson R correlation. Okay. We never know population parameter rho because we never collect the population, entire population. We just have a subset of sample. Okay? We hope the collected sample data are not biased. So whatever we derive from the sample analysis can be guessed, can be predicted in terms of the how the population parameter will be. But actually, we don't know. Okay, so the data collector's roles, data collector's scientific design is actually the most important element. in the statistics analysis, because all the statistics analysis will be messed up if the design is not good enough. So 6700 course is very, very important. Okay, and this class is an extension of 6700. Right? Okay, so now number. See, you see the sense of these numbers. R, Pearson R, 0 on the bottom, right? The strong relationship, 0.9. But this is a negative relationship, right? So minus 0.9. Okay, so absolute value of Pearson correlation from 0 to 1. Perfect relationship between two is 1, and non-relationship is 0. Non-relationship 0 is still regarded as a linear relationship, but the relationship is 0. Sounds weird, but that's the way how mathematically we say, okay? Non-zero, non-relationship is R, Pearson R is 0. Still regarded as a linear, okay? Because it's not non-linear, okay? All right. I'm gonna talk about this next class, okay? Thank you. Bye-bye.